Hey everybody, thanks for joining today's nTop Live about osseointegrative lattice test coupon design. My name is Christopher Cho, and today's session will be a deeper dive into the idea of custom blocks and workflow duplication, and how they can be used to make the manufacturing process easier when it comes to creating the necessary test coupons that are representative of your lattice structure. For those of you not too familiar with what a test coupon is, it's essentially a sacrificial part in your build that will be specifically used for testing. If, for example, you're building 100 orthopedic implants and you want to ideally avoid sacrificing one of those 100 parts to destructive testing methods such as tensile testing and abrasion testing and other such validation steps, this is going to be the right way to go. The alternative, as a result to sacrificing one of those parts, is to fit smaller and functionally representative test coupons somewhere in your additive manufacturing build where they don't take up a lot of space or use a lot of material. Now, there are many other reasons why you would want these coupons and strategies for where you would place them in your build, but today's nTop Live is going to be about using nTop Platform's custom block system to quickly generate basic shapes that are going to take on the form of your test coupon and also show a workflow duplication method that will enable you to use the same lattice structure that was applied to your orthopedic implant and reapply it to your test coupon as well. So what we have here is a tibial tray, which is going to be one of the components of a total knee replacement surgery. And the workflow that we have already created is a quick and easy randomized trabecular structure that was applied to the bone-facing surface in an attempt to imitate the internal bone structure and promote better osseointegration. For the sake of this nTop Live, we can say that this is done, right? After trial and error and testing, this is the structure that we are happy with, and we want to push this into production. Now, in an actual production environment, we may only be able to print a handful of these in each build that we run. So losing even a single one of these parts to destructive testing would be highly detrimental to our bottom line. So instead of doing that, we're going to create a lattice test coupon, apply the same lattice structure that we have on this tray onto that coupon, and we're going to use that one sacrificially instead. Instead of creating these coupons from scratch, I'm going to import one of my custom blocks, which is going to be a simple cylindrical plate with a large surface area that can be used for abrasion testing. With this block, I can apply a diameter, say 40 millimeters, a height, something like 5 millimeters, and an intended thickness for the lattice region. And typically, we find that value to be 1 millimeter. It is important that for this specific value of lattice region thickness, it matches the intended thickness of your lattice design region of the part that you're working with. So in this case, my tibial tray lattice region thickness is 1 millimeter. My test coupon should be representative as such. Now, the position of this coupon is pretty arbitrary during this purely design process, so I could use one of my enhanced translate blocks to just pull it over to the side. And we're going to name that block our lattice coupon geometry. So this lattice coupon geometry is actually a list of two bodies, and we can see that with the two being in parentheses right after the block name. It's going to be made up of a solid region and a lattice design region. So what we need to do is we need to pull these out and work with them separately and discretely. So first, the solid region we're going to pull out, bring this to the front page of the notebook. And we're not going to do anything with this because it's just the solid region. I happen to know that this one is the solid region because I was the one who created this custom block, and we can name it the solid region as such. And the other one we're going to drag out is going to be the lattice design region. And we're going to pull that out and rename it in the exact same way. And by pulling them out of the list, we now have these two discrete objects that we can work with independently. However, if we were to create a brand new lattice design workflow from scratch for this coupon, it would be a little bit redundant because we actually have a faster and more foolproof way to create a lattice design workflow that is connected to the original one from the tibial tray. And this connection is important because the lattice test coupon that we are creating needs to have the same characteristics as the part it's supposed to represent. So what we can actually do is we can go into the trabecular structure block that we have over here, this workflow, and this is the one that defines the randomized structure on the tibial tray. We can right click that, select duplicate, and if we open up this duplicated workflow, we can see that it takes on all the input parameters that were initially used, such as the beam thickness, pore size, and randomization seed. So what we'll do here is actually delete the input geometry and change it to the geometry that we're looking to apply it to. In this case, the new lattice design region for the coupon. I'm going to give that just a moment to run. And we can move some things around for a little bit better housekeeping. There we go. It's finished there. We can hide the visibility on some of these subcomponents. And we can see that it was really easy to reapply the same lattice workflow to an entirely different part, right? So all that's required now is to just rename these blocks and you're good to go. So we're going to rename this our test coupon lattice structure. And we're finished. As a note, it is important to use duplicate in this circumstance and not use duplicate with references for this kind of duplication strategy. When you use the second option, duplicate with references, it has a different copying method and yields a different result that could potentially break the original workflow from your tibial tray. So it is best to avoid that duplication method unless you are familiar with how it works. So with a little bit more housekeeping and good organizational practice, we can bring these blocks into a respective group. Call this our test geometry. And we can add a little bit spacing right at the top for some visual separation. Now to showcase the workflow connectivity, I'm going to change the input pore size of the lattice structure design from 1 millimeter to 1.25. And we'll give it just a moment. But what we can see here is that both the part and the coupon are going to start regenerating their corresponding lattice structures with the new input parameters, right? So with the new value of 1.25, that is now connected to the coupon that we've created. And it's also being reapplied to the structure on the tibial tray. Now, there are a lot of different test coupon configurations out there, and each one serves its own purpose based on functional requirements and business need. However, in the future, we may offer these basic coupon designs as a really quick and easy way for a user to start leveraging these connected design workflows. So from the design to output, nTop platform offers not just a variety of ways to control aspects of your osseointegrative lattice design process, but also a variety of ways to control where and how the design process is applied. Obviously, what I've shown here today is not intended as a be-all and end-all solution when it comes to designing these osseointegrative lattices for your medical devices. There are many different ways to go about this within nTop platform, and this is just an example on how to explore those capabilities. But this has just been a showcase of what nTop can offer as a design platform to create these orthopedic design solutions that work for your specific parts and your specific product lines. Thanks for tuning in, and I look forward to seeing what you make with nTop platform.